welcome to this video on Python programming. In this video we're going to build upon what we discovered in our last video and translate our fractional arithmetic program from Pseudo code into Python code. By the end of this video you'll have a functioning fractional arithmetic program that's been implemented in the Python programming language. Now, looking at what we got up to in the previous video, we had a look at how we add and subtract differing fractions together, and then we went about designing a program in what's known as pseudocode, or a program that's been written in a simple set of instructions that are small enough that you'd hope a computer would understand these. Now what we're going to do today is we're going to get this program here and we're going to convert it line by line into the equivalent code that you would see in a Python program. Now what I'm going to do this is I'm going to grab the first part here, so the get first fraction, and I'm going to show you how we implement this in Python. So I'll just copy it and then go over to REPL. I'm going to start a new REPL project. I just leave it as its default name and I'll say create REPL. Alright, now that we're in, what I'm going to do is I'm just going to paste the information in here. Now obviously if I try to run this, it's just going to give me an error because this isn't valid Python code. Rather, what we need to do is we need to change this, so convert this into actual Python program. So to do that, I'll start off just with my template and I'll go def main colon, then I'll go down, I'll type pass, and I'll go down to the bottom, tab all the way in, and I'll type main. So it's really important that def here and main, they align. And this pass, it's going to be spaced in by 2. Spacing is very important. Now, looking at the first instruction, it says get numerator. So, the way in which we get a numerator, or the way in which we get information from the outside world, is we use the input instruction. And we're going to say import numerator, like so. And this will cue the user to enter the numerator. After that, we have to store the numerator, so this line of code here. So we can't do it on a separate line of code in Python, rather we have to implement these two instructions here on the same line of code. So in here it says store in variable n1. So let's create a variable n1 and we'll say n1 equals the input of the numerator. And then we've got a similar set of instructions for the denominator. So what I can do is I can just copy, paste, and then change the name. So it goes n1 equals input numerator, d1 equals input denominator. Like so. Then we'll just space it out so they're equal. Alright, I've converted this to Python so I don't need it anymore. So I'll get rid of it. And what I'll do is I'll add a little comment in here and I'll say get first fraction, like so. Now let's run. Okay, it says numerator. I'll import our first fraction was 4 over 5. So the numerator is 4, the denominator is 5, and everything seems to be okay. It inputs the two numbers and then closes the program up. So that's what we're expecting it to do. Now let's have a look. If we go down, it says get second fraction. So basically it's the same as what we've implemented over here. So let's have another go. Let's change it up. Let's grab this. We'll go down and we'll paste it. And we've got to make sure that everything's spaced in correctly. So this guy pushed in ever so slightly. We'll move it back. We'll change it to get second fraction. Then we'll go n1 to n2 and d1 to d2. So we want the second. So what we're expecting is the last numerator 1 over 2, then 4 over 5, just as some test data. So everything seems to be working. We can input 2 different fractions now. Alright, let's go back. It says ask user for operation. So get operation and store it in variable op. So let's get these, copy them over, and what we're going to do is get operation, like so. Change it to really low. So once again, we're going to be doing something similar to these first two instructions here. So get first fraction, get second fraction, get operation. So we'll go, the variable name is op. So we'll go op equals input. Then we're going to say operation, question mark. Alright, we don't need these 2 lines of pseudocode anymore. And we'll run. We've got a problem. Inconsistent use of tabs and spaces. So let's have a look. It's going op, input, line 11. So there's a problem with this line here. What could be the problem? Let's just delete it all back. Op equals input, operation. Alright. Let's run that. Okay, that's better. Now, going over, we're expecting 4, 5, 2, and 3, and it's plus. So we'll go 4, 5, 2, 3, and we're going addition. Oops. Addition. And it seems to input all of the information. So we're inputting the first fraction, second fraction, and operation. Now, we want to perform the operation with 2 fractions. So let's get all of this pseudocode here, and we're going to paste it into our Python program. Paste it all in, and then let's implement it one by one. So we go multiply D1 with D2, and that will be stored in variable D3. So what we'll do is we'll go down to this line here, and we'll say D3, so this guy here, is equal to D1 multiplied by D2. So I'm going to use this star symbol here to do multiplication. So this is get common denominator. So the denominator that we're working with, and I shouldn't say get, I should say calculate. Calculate common denominator. Now next one is multiply n1 with d2 and store in variable n1 d2. So we're doing this part up here, n1 multiplied with d2, so this guy. So this is the top, or the first part of our numerator, first term in our numerator. So let's go ahead and do that. We'll go n1 d2 is equal to n1 times d2. And we'll get rid of the pseudocode now, and we'll say calculate the first term in numerator. Now n2 d1 is pretty much the same instruction as what we've done here. So what we'll do is we'll just copy this, paste it in, and then change the variable name. So n2 d1 is n2 times d1. So that was nice and simple. And then finally, we have to deal with the actual operation. So we decide, are we doing addition or are we doing subtraction? This is a little bit confusing for me now. So what I'm going to do is I'm going to get rid of this if, and I'm just going to focus in on this add. So what we can say is n1, we'll say n3 is equal to, and we're going to go add n1 d2 with n2 d1. So we'll go n1 d2 plus n2 d1. Paste it in there. So this is called perform addition, like so. And let's have a look what happens when we run it. So we'll go 4 on 5 plus 2 on 3. 4 on 5 plus 2 on 3. And rather than writing addition, we'll program it to handle the plus symbol like this. And it says, can't multiply sequence by a non-int of type string. So this brings forward the first problem that we're going to have to deal with. The issue is when we input these numbers, N1, D1, N2, D2, and op, what happens is the values that come in, they get stored like they're words as opposed to actual numbers. The way in which I can show you this is I can do a print statement right after this guy here. So we can go print, and we'll go N1 plus D1. And what you're going to find is rather than adding these together, it's simply going to combine them together. So N1, D1, it's 4 on 5. It's going to come, we'd expect it to be 9, but it's going to come out as 45. Rather, we want to make this as, say, 9. So what I'm going to do is I'm going to translate input to an integer, like so. So when I run this, it's going to interpret the input coming on here, so this number here, as an actual number as opposed to a word. So when we add N1 and D1 together, rather than saying it's 45, it's going to say that it is 9. So 4, 5, lo and behold, it comes out as 9. So now we're working with numbers, not letters. So we need to modify this int closing and closing. And we don't have to do anything with this op here because we don't really want to change that just yet. So now let's have a look and run it. We'll go 4 on 5, 2 on 3, 4, 5, 2, 3. Operation is plus. And it seems to be okay now. No complaints whatsoever. But we want to see, is it actually printing what we expect out to the screen? So we'll say print the result is, and then we'll go plus, and we'll say N3 over, and then it will be D3. Now one thing to keep in mind, these letters here, str, it stands for string, and what that's going to do is up here we change the input into numbers, so N2 and D2, they're represented as numbers inside the program. Because these are also represented as numbers, D3, N1, D2, N2, D1, and N3, if we want to be able to display them as words in this print statement, we have to convert them back into words. So this method here, str, or this instruction, is going to change N3 back into a word. So when I run this, it shouldn't complain at me. So we're going to go 4, 5, 2, 3, addition, boom. The result is 22 over 15. Now when we have a look back, have a look. It's exactly as we're expecting it to be. The addition of 4 over 5 plus 2 over 3 is 22 over 15. So the program seems to be working from what we can tell thus far. Now, we have to implement the subtraction. So we've got to deal with this if part in here and deal with the operation. So what we can do is we've got the perform addition here. What we need to do is we'll paste this back in here. And this guy needs to be tabbed in. And what we're going to find is perform addition. This guy belongs over this instruction here. Like so. And down here, this is a subtraction. So basically, rather than a plus here, when we're down here, we expect this plus to turn into a minus. So we can copy this part of the code, paste it over the top here, and then change it to a minus. So this is done if the operation up here is plus, and this is done if the operation up here is minus. So the way in which we can program that is we go over this if, and we type lowercase if, and then we go op equals, and then we can either say addition if you want the user to type addition manually, or you can go plus, like so. Then I'm going to finish it off with this colon, like so. Underneath that, we change else to lowercase else, colon, and then we get rid of this store. Now, we're going to run into a slight issue if we try and run this. It's complaining at me. There we go. We're going to run into a slight issue in that n3 is inside these tabs. What we need to do is we need to type n3 equals 0 just out here for now. This will stop our program from complaining. So if we run this, we'll run the same test data, 4, 5, 2, 3, plus, and lo and behold, 22 over 15, which is still what we're expecting, this improper fraction. But let's test with some test data we have. So I've got 4 over 5 plus 1 over 3. We'll see if that works. (17 over 15), let's check. Indeed it is. Now let's go for the negatives, see if the negatives are working. 4 over 5 minus 1 over 2. (3 over 10). Boom. Seems to be okay. And finally, let's check with this example 3. 3 over 8 minus 2 over 5. Negative 1 over 40. And that's exactly what we're expecting to see here. So, we've got this program running, but not quite happy with this just yet, because if you look at it, it just says numerator, denominator. We don't really know what's happening when this program runs. It's more a case of you need to know and need to expect what you're looking at to understand it. So what we should do is we should clean up the program such that it guides the user through what's actually happening. So one thing we could do is perhaps when the program starts up, rather than just saying numerator, let's make it say, hello, I'm a program that works with fractions. So we'll say print and say, hello, I am a program that works with fractions. We'll go smiley face. And have a look at that. Already much nicer. Hello, I'm a program that works with fractions. Then it asks for the numerator. Now let's change it ever so slightly. Let's be more explicit. Let's say what it does with fractions. So print, and we'll say let's add or subtract some fractions. Not some, we'll go two fractions. Now running. Hello, I'm a program that works with fractions. Let's add or subtract two fractions. Alright, so this is starting to make more sense. Now let's actually tell the user that we want to get the first fraction. So we'll say print, and we'll space it in by 2. And we'll say, tell me about the first fraction. Running. And look, it says, hello, I'm a program that works with fractions. Let's add or subtract two fractions. Tell me about the first fraction. And then it asks for numerator. Now notice numerator is spaced all the way to the left. Technically it doesn't matter if it is, but it would make more sense if the program starts going inwards. So we'll get the spacing in here and we'll move denominator and numerator inwards. So that way we can see what we're actually working with. So tell me about the first fraction, and then ask for the numerator and denominator. So it was 4 on 5, the first one. Now let's clean up the second fraction here. So grab this stuff, move it down, paste it in, and we'll say, tell me about the second fraction. Then we'll space numerator and denominator in respectively as well. Okay, 4 on 5, 1 on 2. And already what you can see is the program's starting to look easier to read, and it's more detailed in what we're actually expecting the program to do. So when it starts up, you know that it's a program that works with fractions, and you know you're either going to add or subtract two fractions together. And the program's guiding you through the process. Now, let's clean it up. Rather than saying just operation, let's say space it in. What operation would you like to perform? Or would you like to add or subtract? Question mark. Run 4, 5, 1, 2. Would you like to add or subtract? We will add. And lo and behold, seems to work accordingly. The only final thing we can do to clean it all up, we can say the result is, and 5 over 4, 3 over 2, we will subtract, and voila. This program seems to be working as we'd expect it to. We'll move this in ever so slightly again. Go 1 over 2, 4 over 5, add, and yeah, this is looking a lot nicer. So when we're running this program, it actually shows the user what's going on and guides them through the entire process. So this would be a complete program here. Now let's have a look back. In the very start of the lesson, we had set out to translate our fractional arithmetic program from pseudocode into Python code. So we wanted to change this over here into this over here. And I think we were successful in that. Now let's have a look at our success criteria. So by the end of this lesson, we will have a functioning fractional arithmetic program implemented in the Python programming language. So having a look, we indeed do have a functional and running program in the Python programming language.